we are looking at partial differential equations, especially second order and higher homogeneous partial differential equations, and we're going to see how we can solve them and get a general solution. So we are going to start with an example, but before we start with an example, I just want to explain a few things. So with this concept, we are looking at a function whereby you are given a function d prime. We are looking at a function d prime we are looking at a function d prime of z, which is equal to f of x y, like this one. So with this one, we are tasked to find the solution. So z is just a function of x and y. So our solution will be the cumulative function. Our solution will be the cumulative function plus the particular integral. So if we are given a partial differential equation, so we are tasked to find the solution, the general solution. So this is what we are expecting, especially if we are looking at second order or higher partial differential equations that are homogeneous. So in our case, let's just dive deep into one of examples so that you can see how we evaluate this. So this is the notation that we're going to use. We're using the d operator. So d is d dx, d prime is d dy, 1 over d is going to be the integral with respect to x, 1 over d prime is going to be the integral with respect to y. So this is the notation. This is what we are going to be using. So instead of d dx, we're going to just use d. Instead of d dy, d prime. It's same with this. So if you are given an equation whereby now you are tasked to solve, d squared minus 4d d prime minus 4d d prime plus 4d prime squared z, which is equals to xy plus e 2x plus y. So we want to solve this one and find the general solution. So the first thing that you do, in order for you to find the general solution, you need to find the cumulative function first. So you remember, when you're finding the cumulative function, we need to determine the auxiliary equation. Then from the auxiliary equation, we determine the values of m. If you're using m as your variable, or whatever variable that you use to find the roots for the auxiliary equation, then you can find the cumulative function. So here, how do you determine the auxiliary equation? We are going to say let d to be m and d prime to be 1. So from here, we are going to have, which means we are going to substitute this here inside and equate that to 0. So we are going to have m squared minus 4m plus 4 is equals to 0. So from here, we can see m minus 2 if you work this out. Therefore, m is equals to 2. It's the same. So now your cumulative function will be f1. This is how you represent it, y plus 2x plus, since it's the same here, we're going to add x, f2 y plus 2x. Let's say maybe m with distinct or two distinct values like this. How are we going to write the cumulative function? We are going to write it like this: f1 y minus x, since this one is negative, plus f2 y plus 3x since this is positive, and you see now we don't have x here because there are two distinct values of m. So from here, okay, coming back to our initial question, so from here now we have determined, now we have found the cumulative function. Now let's find the particular integral. So this is where you need to be careful when you're finding the particular integral. I'm just going to name it v. This is how you represent it. For the particular integral, there are certain things that you have to know based on the functions that you're given on the right hand side. So you come back to your initial equation. So you look at the right hand side, you're given polynomial exponential. So there are certain things that you have to know about the polynomial and the exponential. So if you have a function d prime, which is equals to eax plus by, which is a polynomial, the particular integral will be the particular integral is just going to be eax plus by over f d prime, where d is a and d prime is b. Same thing if you're given a function of d prime where you have x to the power m, y to the power n. Same thing here. We are going to have your polynomial to be evaluated using a binomial expansion. And with the binomial expansion, we won't necessarily use the formula, but we are going to use this series 1 plus x, which evaluates 1 plus x, 1 plus x squared, 1 plus x cubed, 1 plus, it continues. So this is just an expression that can evaluate into this format. So we are going to use this expression. So then how do you apply this? So now we need to rewrite our particular integral in these two formats. So again, for this one, the particular integral for this was going to be xm yn over f of d prime. So let's write this. So your particular integral, which I'm going to name v, is going to be e2x plus y over, this is going to be e2x plus y over d squared minus 4d d prime plus 4d prime squared plus xy over d squared minus 4d d prime plus 4d prime squared, which is this format and this format. So now we are here. We need to further evaluate this. How do you further evaluate this? So I'm going to be doing it simultaneously. So I'm starting with this side. So how do you evaluate this? So we know that d is a, d prime is b. So, and we know that a from this is what? Is 2, and then b is 1, right? Which means now we can work this out. So we are going to substitute the denominator using these two values. So v is going to be e to x plus y over d squared is going to be 2 squared minus 4, 2, 1 plus 4, 1 squared. This is going to be, So how do we evaluate this side using the binomial? First of all, this is the same. We just need to factor out on the denominator. The first thing that you do, you factor out d squared. So you're going to have xy. If you factor out d squared, what do you get? You're going to get 1 minus 4d prime over d plus 4d prime squared over d squared. So this is what you get. So now simplify this. You're going to get e to x plus y over. So if you simplify, if you evaluate calculate the denominator, we are going to get 0 plus. So from here, what do? You rewrite this as x y over d squared. D squared, this is going to be 1, and then between these two you factor out negative, so you're going to have 4d prime over d minus 4d prime squared over d squared. So this is how you rewrite this in that format. Why are we writing this in this format? Because we want to have something like this, remember. So our x is sort of like this variable here. So this is going to be since here, okay, let me start with this one. Since here we have 0, we need to do something to the original expression. So since we have 0 here, we are going to differentiate the denominator with respect to d, the denominator of the exponential function. This is the denominator, so we need to differentiate it with respect to d. So this is d squared. We're differentiating d squared minus 4 d prime plus 4d prime squared. So now if we differentiate this with respect to, we're going to get d 2d minus 4d prime if we're differentiating with respect to this. So now, since this is going to be a constant because it's d prime is a constant here because we're differentiating with respect to d. So this is going to be, this is what you're getting. So we can, if whenever you get your denominator as 0, when you're evaluating the function of an exponential, you get your denominator to be 0, you need to differentiate the original form of the denominator, and then after differentiating, you're going to multiply the numerator, the exponential function itself, by x. So v is going to be x e to x plus y over the new derivative, which is 4 prime plus. So here, allow me to take this to the numerator so that I can have that expression raised to the power -1. So here I'm going to have 1 over d squared, 1 minus 4d prime over d minus 4d prime squared over d squared, and then this is all raised to the power -1, and we have xy. So now from here, again for the exponential, we know that d is a is 2, and then d prime is b, which is 1. Substitute again here, so we're going to have 2, where d is 2 minus 4, d prime is, we're still getting 0 again. So we have v is equals to x e to x plus y over 0 plus 1 over d squared, 1 minus 4d prime over d minus 4d prime squared over d squared. This is minus 1 xy, right? So now again, since we're getting 0 here, which means we need to differentiate this with respect to d again, so d is going to be 2d minus 4d prime. So this is going to be, remember, prime d prime is what is a constant, so here you're just going to get 2. So we can rewrite that as v is equals to x e 2x plus y over 2. And then since we differentiated, we need to multiply again the numerator with what? We need to multiply it with x again. So this is going to be x squared, and then plus 1 over d squared 1 minus 4d prime over d minus 4d prime squared over d squared. This is minus 1 xy. So now from this point, what do? We are done with the exponential. We've evaluated the denominator to a constant, so that's good. And then now we need to focus on the polynomial xy. So now we have written this, so let's expand this. Let's expand this this binomial expansion. So here we are going to have v is equals to x squared e 2x plus y over 2 plus 1 over d squared. If we rewrite this into the format of 1 minus x minus 1 is equals to 1 plus x squared, we're going to have let me erase this, which means we're going to have 1 plus your x, which is 4d prime d minus 4d prime squared d squared plus x squared 4d prime over d minus 4d prime squared over d squared. This is squared plus this will continue, and we're evaluating xy. So let me just write these 3 terms. So now how do you simplify, because this is an infinite series? So how do you simplify this infinite series? So remember, here we are looking at evaluating xy. We are looking at evaluating xy using the d operators. So first of all, we know that d prime is what is del y. So which means if we differentiate this one with respect to y, we are going to get x, and then if we differentiate again, you're going to get 0, then 0, 0, 0, right? If we continue differentiating. So what does this mean? So when you're looking at the infinite expression here, you're looking at the infinite expression here, which means if we are taking terms if we are taking the terms here with the highest power, if we are taking the terms here with the highest power of d prime, especially if d prime is squared or cubed or to the power 4, those one won't work for us because we're just going to get 0. So we are going to take the terms with d prime only, because if you evaluate d prime of xy, this is going to be x, right? So from here, which means this entire term will give us 0, and also this term will give us 0. So we are going to have v is equals to x squared e 2x plus y over 2 plus 1 over d squared. So this is going to be 1, this first term plus this term, which is 4d prime over d. So now this is where we are, and obviously we have xy, which is xy was here. So now let's further simplify these parts. How do you simplify that part? First of all, let's xy multiply everything that is inside the bracket. So we are going to get plus, this is 2. So we are going to get plus 1 over d squared of xy plus 4d prime xy over d. So let's evaluate 4d prime xy. What is this? It's the same thing as 4 times d dy of xy. Remember, I stated that in the beginning of the video, so this is going to be 4x. So here we can just write 4x, right? And then which means we have 1 over d 4x because of this d. So we know that 1 over d is the integral of 4x with respect to x. So this is going to be 2x squared. So now instead of these, we can just write 2x squared. So 2x squared. So we can rewrite the entire particular integral is e 2x plus y over 2 plus 1 over d squared of xy plus 2x squared, like this. So again, we need to evaluate these parts of the operator. So 1 over d squared xy plus 2x squared is the same thing as 1 over d times 1 over d of xy plus 2x squared. So if we evaluate the first 1 over d, we are going to have 1 over d, which is this one, the integration of xy plus 2x squared dx, since it's d. So let's integrate that. If we integrate that, we are going to get with respect to x, integrating using the direct integration with respect to x, which means y is a constant. So this is going to be x squared y over 2 plus we're going to have 2x cubed over 3, and then again evaluate this d, which is going to be equal to the integral of x squared y over 2 plus 2x cubed over 3 dx. So this is going to be what if we integrate with respect to x cubed y over 6 plus this is going to be x to the power 4 over 6, which is x cubed y plus x to the power 4 all over 6. So now we can rewrite our particular integral to be equals to e x squared e 2x plus y over 2 plus this is x cubed y plus x4 over 6. So now we have found the particular integral. We can just go to the so our solution, our general solution, we say this should be the cumulative function plus the particular integral. So our general solution, the cumulative function we got, that is f1 y plus 2 plus x f2 y plus 2 or plus 2x plus 2x, like this. And then now we need to add the particular integral, which is x squared e 2x plus y over 2 plus x cubed y plus x to the power 4 over 6. So now this is our entire solution for this problem. So this is how you basically solve a second or higher order partial differential equation, especially if it's whether it's homogeneous or you are given functions or non-homogeneous. So this is how you solve it. First of all, you find the auxiliary equation, and after finding the auxiliary equation, this is the auxiliary equation here. auxiliary equation. After finding the auxiliary equation, you can get the cumulative function, and then we look for the particular integral, and then you combine the two to get your general solution. So this is how we were supposed to do this question. So thank you for watching.